Hey, welcome to Algebra 2. I hope everyone had a nice weekend. We are so close to holiday break here. So keep working hard. We do have a quiz coming up on Thursday or Friday. So we are almost there, but keep it up, okay? Take a look. This is a warm-up. We're going to do a little review before we get into the lesson. So we have a division problem, dividing rational expressions. It says Jane's work. Oh, there we go. Jane's work is shown on the right here, okay? So she made an error. Jane's not smart like you. Find the error and correct it. So what I would do is recommend doing this problem on the left and see where your work doesn't match up with Jane's work. All right, line 1, line 2, line 3, where's her mistake? All right, if you said line 2, you would be correct, okay? Now, you have to do the problem yourself to kind of see where her mistake is. But remember, when we're doing these type of problems, we keep this side the same, we switch this to multiplication, and then we flip this. We flip it, and we're multiplying by the reciprocal. So Jane here didn't flip. She didn't flip. All right, let's take a look at the work on the next page. So if you have any questions, you can figure out how to do it. All right, here's the factored form. Again, when we do division, we want to start canceling out factors after we keep switch flip, but we have to factor them first. So all 4 of these can be factored, right? Trinomial, a couple GCFs. The top right here, once you take out a GCF, we get difference of squares, okay? Now, at this point, we're going to keep the left-hand side the same. So we have x minus 9 times x plus 5. Keep the bottom the same. We switch this to multiplication, and now we're multiplying by the reciprocal. We flip this upside down. So the x times x minus 5 is on top. The 6 times x plus 5, x minus 5 is on the bottom. There we go, that's a little better. Okay, at this point, this is the fun part because remember, we get to cancel out factors. If you see something on the top, oh, I don't know why you wrote 3x minus 15. We factored this, right? 3x 3 times x minus 5. Okay, everything's factored now. When you see something on top that matches up with something on the bottom, cross it out. So we have an x minus 5 and an x minus 5. You got to go. We have an x plus 5 and an x plus 5. I don't see anything else that can cancel out, so we just write what's left. We have an x on top, and we have an x minus 9. And on the bottom, we have a 3. We have an x minus 5, and we have a 6. So 3 times 6. All right, x times x minus 9 over 18 times x minus 5. Nothing else I can cancel out. There's my answer. Also, we need to make sure we include those excluded values. So anytime you see a factor with an x in it, set it equal to 0, okay? Now, so x minus 5 here on the bottom left, that means x cannot equal positive 5, because if we plug in 5 minus 5 is 0, you'd be dividing by 0. Don't do it, okay? We also have the x plus 5 here. That means x cannot equal negative 5. We also have an x minus 5. We already did that. So we have 5, negative 5. Now remember, we flipped this upside down, so we also need to take a look at that x squared minus 5x, which is really the x times x minus 5. The x minus 5, we already did that. Now we also have the x. So you set that equal to 0, so x cannot equal 0, because if you plug in 0, you would have 0 times negative 5, which is dividing by 0. So there's my excluded values. There's my answer. Division done. All right, moving on. Last week, we also took a look at addition, okay? Remember, when you're adding fractions, if we have 1/4 plus 1/2, we need a LCD, least common denominator, to add these up, okay? So start by factoring, then come up with an LCD. Happens here that we can't factor anything, so my LCD, we're going to look at the denominators, has to have a 2, has to have an x, right? They have to be on that list to go to the LCD party. And we also have an x squared. So x squared, we need 2 x's on this list. We only have 1, so I need to add another 1 to make it x squared, okay? Now, remember, we want both of these denominators to look like that LCD. So this 2x needs to look like 2x squared. The only thing missing is x. So I'm going to multiply to create that common denominator. So I'm going to multiply by x over x. On the right-hand side, we have the x squared. It's missing the 2. So I'm going to multiply by 2 over 2. All right. Next step here, on top, we have just 4 times x, so 4x over that common denominator, which is 2x squared, plus on the right-hand side, I have x plus 1 times 2. Make sure we distribute that 2. So we have 2x plus 2 over that common denominator. At this point, we just combine the numerator. So we have 4x plus 2x plus 2 over that common denominator. Just combine like terms a little bit. We have 4x plus 2x is 6x plus 2 over 2x squared. Now, this looks pretty good, but I noticed that on the top, 6x plus 2, I can actually take out a 2 from both terms. So I have 2 times 3x plus 1 over 2x squared. You might be wondering why I did that, because I created a factor that I can now cancel. All right, I have a 2 on top, 2 on the bottom. Those go away. So now I'm just left with 3x plus 1 over x squared. All right, can I cancel out an x and an x? No, cannot. Those are terms. We can't cancel out terms, okay? So everything has to be factored, and we can start canceling out factors, right? Products, but not terms, right? 3x plus 1, we're just taking a little chunk of that whole thing, can't do it, okay? All right, last thing, excluded values. Take a look at the denominator. We just have 2x squared. What value of x would make that equal to 0? 0, right? If we plug in x equals 0, we would have 0 and be dividing by it. That's my excluded value. There we go. Addition done. All right, here's the lesson for today. 9.3, solving rational equations. When you see the word equation, what are we going to have in these problems? We're going to have an equal sign. That's right. Your answer should also now look like x equals something, okay? When you're solving an equation, x equals something. That's your answer, or y equals something. Okay, these are not what we're going to be doing today. We're going to make it a little harder than this, but just take a look at basics so you can remember how we do these types of problems. If I have 3 over 7 equals x over 7, what do you think x equals? That's right. 3 over 7 equals x over 7. There's no other way that this could be equal unless x is equal to 3. So 3 over 7 equals 3 over 7, right? All right. A little harder here. If we have 2 over 10 plus 2 over 10 equals x over 10, what do you think x equals? Well, on the left-hand side, this would be 4 over 10 equals x over 10. So x has to equal 4, right, for those to be equal. So think of this. Now, when we're doing these problems, the reason we could do this is because 10, 10, and 10, these are all the same, right? So once we know that the denominators are equivalent, so do the numerators. They have to also be equivalent. So keep that in mind as we take a look at a couple problems together. All right, this is what we're doing today. Take a look. We have a rational equation. Again, we have an equal sign. Write the problem down and then write these steps down over here, okay? We're going to factor the denominators. We're going to make all the denominators the same, equal, okay? So we need an LCD. Then we're going to cancel the denominators and we can just solve the numerators, right? If the denominators are the same, the numerators also have to be the same. And then we're just going to check to make sure our solution is not an excluded value. All right, have these down. That way you can take a look at them if you're solving a problem and go through those steps. Okay, here's my problem. Step 1, factor the denominators. All right, I can't even factor the numerators on these, so I'm just going to factor what I can, which is the denominators, right? On the bottom left, I have 6x minus 30. All I can do here is take a GCF, and we always want to look for a GCF anyway. I can take out a 6, and if I do that, I'm left with x minus 5. All right, is equal to, we're going to now take a GCF from 4x minus 20. I can take out a 4 from the 4 and the negative 20. If I do that, I'm left with x minus 5. All right. To solve this problem, we need an LCD, right? We want both of these denominators to be the same, okay? Now, it has to have a 6, and it has to have an x minus 5. Now I go to the right, and it also has to have an x minus 5, and it also has to have a 4, okay? So basically, we need the LCD from between 6 and 4. If you multiply these together, we have 6 times 4 is 24, but you might notice that 6 and 4 also go into 12, okay? So when you're finding the LCD between two numbers, Usually if you multiply them together, 6 times 4, you get 24. Divide that by 2 and see if both numbers also go into that. So 6 goes into 12, 4 goes into 12. Remember, we want the least common denominator, so we want the smallest possible, so it makes our life a little easier. All right, we're going to make both denominators look like this. On the left-hand side, we have 6 times x minus 5. I need it to be 12 times x minus 5, so what do I have to multiply by? That's right, 2 over 2, okay? Same on top, same on the bottom. On the right, I have 4 x minus 5. I need it to be 12 times x minus 5. I need to multiply by 3 over 3. Okay, at this point, we are going to write out, we're going to distribute the 2. That's why I put parentheses around that binomial, so you make sure you multiply everything by 2. 6x plus 22 over, now again, we've created the same denominator. On the right-hand side, again, distribute that 3, 3x plus 36, over that same denominator. Now, again, if the denominators are the same, right? They are. That means the numerators also have to be the same. So we're just basically going to cancel out those denominators, and we're going to create a little equation with just the numerators. All right, let's flash back 2 years ago when we were in school to Algebra 1, solving a 2-step equation here. Get the x's on one side, everything else on the other. So we're going to start by, I usually take the smaller x's and subtract those. So subtract 3x from both sides. So I'm left with 3x plus 22 is equal to 36. We want the x's by itself, so we're going to take the 22 and get rid of it by doing the opposite. 3x equals, what do we got, 14? Divide by 3. I'm just staying with pink because we're on a roll. X equals 14 thirds. All right, there we go. My excluded values, we just need to make sure this works for us. Take a look at the denominator. They're the same. X minus 5, what value can I not plug in? X cannot equal 5 because I'd be dividing by 0. That's my excluded value. 14 over 3 is not an excluded value, so now I can just square it again, okay? Just to confirm that's my answer. All right. Finish writing that down. We're going to take a look at one more here together. Okay, a little more difficult here. X over 3 plus x plus 1 over x plus 2 equals x. Now you might notice we have 3 different things here. Also, you might notice this x doesn't have a denominator. If it doesn't have a denominator, we're just going to put it over 1, okay? Right? That way we can make all those denominators the same. Okay, step 1, factor everything. I can't factor anything here, so I need to now just come up with my LCD. What's my common denominator between a 3, a 1, and an x plus 2? Well, between 3 and 1, it has to have a 3, and then it has to have an x plus 2. All right, there's my LCD. Let's make all those denominators look like that. Let me rewrite the problem here so we get a little more room. X over 3 plus x plus 1 over x plus 2 equals x over 1. So we're going to have to make all 3 of these the same so we can solve this problem. On the left-hand side, I have a 3. I'm missing the x plus 2. So let's multiply by x plus 2 over x plus 2. In the middle term, I have the x plus 2. I'm missing the 3. So let's multiply by 3 over 3. On the right-hand side, I have a 1. So I'm missing the 3 and the x plus 2. So 3 times x plus 2 over 3 times x plus 2. Okay, lots of multiplying out here. Okay, top left, again, make sure we distribute. That's why I have those parentheses. I have x squared plus 2x over that LCD. All right, middle term, distribute that 3x plus 3 over that common denominator equals, all right, I have x times 3 times x plus 2. There's a couple ways you can do this, but you multiply 3 things together. You're just going to take 2 of them and multiply them, and then multiply by the third. So I'm going to start with the 3 times x plus 2, and I get 3x plus 6. And now I'm going to take that and multiply it by x, okay? So I get 3x squared plus 6x over 3 times x plus 2. All right, at this point, denominator is the same. That means the numerators have to be the same. So cancel out the denominators. And we're just going to make a little equation with the numerators. X squared plus 2x plus 3x plus 3 equals 3x squared plus 6. Before we start moving things to the left and right, I have a couple like terms here. I have 2x plus 3x. So let's add those together. X squared plus 5x plus 3 equals 3x squared plus 6. All right, now let's start moving stuff over. Here's the thing. I have a quadratic, right? So I can't just make x equals to 5. Okay, how do we solve a quadratic? I have to set everything equal to 0, and then we're going to use the ways that we've learned previously. So let's move everything to the right-hand side. Okay, I'm going to subtract x squared. I'm going to subtract 5x, and I'm going to subtract 3. All right, if I do this, everything goes away from the left-hand side. I'm just left with 0. On the right-hand side, I have 3x squared minus x squared is 2x squared. I have, let's go in order here, I have minus 5x. I just have nothing to subtract it from. And I have 6 minus 3 is plus 3. Okay, this might look familiar. 0 equals to a trinomial. You might remember, how do we solve a quadratic that's equal to 0? We're going to factor, right? Okay. This one's a little harder because we have that 2, which we don't love, but we could do it. So these first two terms have to multiply to 2x squared. So I have to have 2x and x. These last two terms have to multiply to 3. So it has to be 3 and 1. Now we just have to play around a little bit. It could be 1 and 3. It could be 3 and 1. I'm just going to go with my gut and put 1 and 3. And now we just have to try those inside and outside terms, right? We're reverse foiling here to see if they add up to negative 5. So 1x, 6x. Can these add up to negative 5? They can. Let's see. I would need negative 6x. The only thing here, this one's kind of tricky. If I put negative 3 and positive 1, if I multiply 1 times negative 3, I'm getting negative 3 instead of positive 3. So that one's tricky because I can get there, but it doesn't. So instead of 1 and 3, let's try 3 and 1. This one's a little harder. All right, I have 3x and 2x. Again, both of these terms have to be negative to get me to positive 3 when I multiply them. So I can get to negative 5x if both of these are negative. All right, that was a little trickier. You might not see one that difficult, but we spent some time factoring. So just FOIL it back out, double check your work. Okay, at this point, factor times a factor equals 0. Something times something equals 0. You set each something equal to 0, okay? So we have 2x minus 3 equal to 0, and we have x minus 1 equal to 0. Solve each of these. I get 2x equals 3, x equals 3 halves. And I get x minus 1 equals 0, x equals 1. Okay, two answers, right? When you solve a quadratic, you get two answers. We need to check these against our excluded values. Let's go back up to the top. In our denominator, the only place that there was an x was x plus 2. The only value we cannot have, x cannot equal, let me change from highlighter, x cannot equal negative 2, right? If we plug in negative 2 plus 2, we'd be dividing by 0. Let's check our answers. None of them equal that, so we can box those again confidently and say, hey, we got them. All right, so we get two answers, x equals 1, x equals 3 halves. All right, it is word problem time. This is where these problems come in handy, where we can solve rational equations in situations like this. So in preparation for baseball season at Carlsbad High School, a team starts picking weeds from their field. It's been a while since they've been out there picking weeds. The baseball team can pick all of the weeds in 10 hours, and the softball team's nice, and they decide to help out. So they can pick all the weeds in 7 hours. How long would it take to pick all of the weeds if they worked together. So take a guess real quick. If the baseball team takes 10 hours, the softball team 7 hours, how long together? All right, let's see if you were right. Okay, take a look at the bottom. I would copy this down. This is what we're going to do. We're going to use this formula down here. It's not as hard as it looks. All right, this is how I do it. Basically, the baseball team can pick one field in 10 hours. Okay, the softball team, right? They're doing it together, so we're adding them together. The softball team can do one field in 7 hours. How long would it take to pick one field? Well, so one field in 10 hours plus one field in 7 hours equals one field in X amount of hours, okay? So on the bottom here, this is how many hours it takes. So one field 10 hours, one field in 7 hours, adding them together, they can pick one field in X hours. So we have the setup. That's probably the hard part. Now we need to do what we do with solving rational equations. Okay, we're factoring, everything's factored. I just need an LCD between 10, 7, and X. So between 10 and 7, multiply them together, 70, can't divide by 2, that would be 35. 10 doesn't go into 35. So my LCD is 70, and then it also needs an X, 70X. All right, we need all of those to look like 70X. So 1 over 10, how do I get 10 to 70X? What do I need to multiply by? That's right, 7X over 7X. 1/7, 7, how do I get 7 to 70X? What do I need to multiply by? 10X over 10X. And then on the right-hand side of my equation, 1X, X to get to 70X, I just need to multiply by 70. All right, let's multiply out. We have 7X over 70X, right? 7X times 10 is 70X, plus 10X over 70X equals to 70 over 70X. Again, creating an LCD because now those go away. Okay, if the bottoms are the same, the tops also have to be the same. We're just going to create a little equation here where 7X plus 10X equals 70. 7X plus 10X is 17X equals 70. Let's divide both sides by 17. And if we do that, we get X equals, how long is it taking us? 4.1 hours if they work together, all right? Take a look, that makes sense, right? 10 hours, 7 hours, 4 hours together. Yeah, makes sense to me. All right, before you leave, let's try one on your own. So go ahead and solve this equation right here. All right, step 1, factor, right? So you're going to factor the denominators. From there, we need to create an LCD, which would be x minus 2 times x plus 1. So on the left, we have to multiply by x minus 2. On the right, we don't have to do anything. We're going to clear the denominator since they're the same, and we're going to solve for the numerator. All right, clear them, we get x times x minus 2 equals 5x minus 10. We need to distribute that x, okay? All right, so we get x squared minus 2x equals 5x minus 10. How do we solve quadratics? Set it equal to 0. We're going to have to factor. X minus 5, x minus 2 equals to 0. All right, if you solve each of these, you get x minus 5 equals to 0. So x equals 5. You get x minus 2 equals to 0, so x equals 2. Now, last thing here, right, before we double box these, we need to make sure that these aren't excluded values. So take a look at our denominator. We have x minus 2. That means x cannot equal 2. X minus 1, or x plus 1, x cannot equal negative 1. Well, we just said x cannot equal 2. So you know what we do? We have to come down here, and we have to cross that off. It just looks like an answer. It's not. We're just left with x plus 5 as our only answer. All right, nice job today. There is some homework for you to do. Wednesday, I think, will be a little review before that quiz on Thursday. So if you have any questions, please come see me. If not, good luck on the homework. Bye.